How are you doing, guys? Great. Hey, you got the best spot, I must say. It's just like he's like in front of the whole stage. Okay, guys. So welcome on my session. Thank you for coming. My name is Paula J. And Paula Januszkiewicz, and what am I doing for a living? It's very simple, yes. I got a company, it's called Secure. I have established it 8 years ago, and what we are doing, we're delivering different kinds of security projects, including and especially penetration tests. Me personally, I'm the person that is on the one side is the technology, which is my passion since forever, and I'm doing all the security researches with my team. And on the other side, it's I'm also, of course, engaged in the whole idea of the company, including one thing that we have created 3 years ago, which is called Secure Academy. I'm going to give you some small surprise at the end of the session afterwards regarding this. So, what the session is about? The session is about, yeah, exactly, why you are here. Why you are here? What do you want to know about the users? Are they like dangerous for you? Yes. Do you like them? No? That's kind of like, I thought. Yes, I would like to, during this presentation, show you different kinds of scenarios and different kinds of possibilities that users can bring into our infrastructure, especially the ones that were very famous last days or last months or even more than a year, which was simply speaking called CryptoLocker. And I'm pretty sure that that affected you or your friends, the colleagues you know, or at least you read it in a newspaper, what kind of problems that kind of solutions bring to the field. During this session, I would like to show you how to prevent that, how we are able to protect from the code like that to run, and obviously what kind of possibilities are on the user side. Does it work? It's okay? Good. So, whenever we are thinking about of course, different kinds of user-related issues. One thing that I have to mention is that this session, as you see, there's a lot of us. It's going to be running tomorrow as a repeat. So if you would like to listen to it one more time for a reason, yes, it's going to be also at 3 p.m. Pretty much at the same time. At 10:45 a.m. tomorrow. So check out. It's already on the website. I already saw that. Okay, guys, so whenever we are thinking about some statistics, I know that statistics are kind of boring, but these ones are actually quite nice. So especially the one with the 87%. Can you believe that 87% of the companies, they did not, according to statistics, receive any kind of user security awareness training? Yes. This is really unbelievable because I will tell you that I'm a huge fan of delivering different kinds of social engineering tests. And only once in my 13-year career with IT, there was one lady that she asked me, "Excuse me, I don't know who you are. I'm going to call my manager and I'm going to verify if you are really working over here." Before we proceed to the whole scenario, let me share with you a tiny story. So that was the penetration test that I delivered not really long time ago. And that particular penetration test was starting with the social engineering. So this particular company, well, I wanted to get to the building. Obviously, I was the one to deliver it. I wonder why. Probably I look like a very dangerous person. You don't have to confirm that. So what was happening is that there was this 3 entrances. One entrance was the door that is closing and now automatically opening like this. So very easy to get inside, even though I have to have a pass. But it's just enough to do something that we normally call tailing. So stick to some very nice guy's back. I'm sorry, apologies. I'm using what I've got. Yes, it's a social engineering. So I did. The next stage to get inside to this company, there was this kind of elevator where someone had to push the button which floor this person wants to go to with this pin, with this kind of pad. So I wanted to go to the certain floor. Let's say it was the 6th floor. But the reason why, obviously, I want to go to the 6th floor, not to any other floor within this company, is because if I announce myself, there's going to be this very nice receptionist sitting, and she's going to be like, welcome, please sign yourself in the book, who you want to visit, I'm going to call this person, blah, blah. I want to be stealth. So I am in the mood for getting somewhere else, to the other floors. So I'm waiting, literally leveraging my, and apologies, female thing, yes. So what I did, I took my bag, which obviously is bottomless, yes, there is everything, probably some animals are there as well. So I pretty much took this, and I was like searching for something. Obviously, I don't know where things are, yes. Stereotype, maybe, maybe not. So I was searching for that, and I was watching if this guy is pressing the button or anybody. And there was this very handsome guy that he pressed the button and to go to this 6th floor. So what I did, I immediately jumped in to the elevator, to the back side of it. Question is why I did that. And it's a question to you.
He doesn't remember your face?
Good point. We need to cooperate one day. So he doesn't remember my face. Well, yeah, that particularly today, that wasn't the case.
You can sneak into the 6th floor with him after the door.
Exactly. Oh, very good. So I can sneak after him. Exactly. But you know what? I wasn't sneaking. He just was a gentleman. So when we got to the 6th floor, the door of the elevator opened. He literally jumped out. He took his card. He did pip, opened the door, and he says, ladies first. Very good. So I'm already in a company. And can you believe that that was actually a company that was doing a lot of things with finance? So dollars are very important over there. There were desks where there were different kinds of people that were trading different resources. And can you believe that when they finished all the deals, all the things that they were doing, they were like, hey guys, lunchtime. They stood up, they went out. None of the desktops locked. So what is really amazing is that, and don't get me wrong, I really like to provoke the situations. So I literally sat on, let's call him John's desk, and I did this kind of very rude think pose, like this, like, I'm so bored, yes? And what was the thing is that everybody that was like passing by, they were like saying hi to me. People are so nice. And I was like, hi, hi. And someone even told me, hi again. I'm like, hi again? Have we ever met? Yes? So nobody really told me, what are you doing over here, girl? Like, I don't know you. It's the first time I see you. Like, why you're sitting on a John's desk? Because people, they assume that the other people know what they are doing. And that they are in the correct place, in the correct time, which is completely the opposite. If it's about the security and whole social engineering part. So 87%, I'm not surprised. We've got these attacks, Target or whatever, yes, Sony and a couple of other things. Why did it happen? Because hackers are smart? Nah, because users lack training. Because people allow the situations. That is the problem. So, well, we all know that. So the truth is that always to the users, we've got a little bit of mixed feelings. We kind of like them because we have to. But if it's about us here having a discussion about them, we really don't like them. But we have to accept them, we have to respect them, and we have to, and that's what this session is about, create the environment that will take the people out of this chain, security chain, where we call that the weakest link is human. Is human a robot? So that we are calling the human like this? We've got a BitLocker, UpLocker, this, but the weakest chain is human. Is human a robot? They aren't. So why we are really encountering them? Why don't we create an environment that's going to be perfect? Sounds like super idyllic, I know. And it's very difficult, but that should be our goal. To create an environment that will not make humans that are not specialists on security at all. I mean, imagine accountant department being specialists on security. I don't want to even imagine that, yes? So that's my point. Whenever you've got people from the accountant department, they should be working in a comfortable environment that is secure enough to handle their ideas. So whenever we are thinking about all those ideas, that's pretty much the whole session agenda. Good intentions, simply malicious intentions, and the summary. So I divided the session into two parts. One thing that I'm pretty sure you've noticed, and it's not a big secret, that people are using, when I was designing this presentation, I was like, what kind of word should I use? Simple? Nah. No, they're pathetic. Pathetic passwords, they use those. When I was delivering a security awareness presentation for one of the management in the company, could you believe I showed the list of the passwords that are simple? I just made them up. 1, 2, 3, 4, 5, 6, password 1, and that kind of stuff. One of the guys entered, he saw the slide, and he was like, whoa, 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 whoa. I'm like, what, whoa, whoa, whoa. It's like, how did you manage to get my password? I'm like, I just did. Yes? So whenever we are thinking about those, question is, should we check on the passwords of the users? And answer is yes, because we are responsible for maintaining the security awareness over here. But is this ethical or not? Well, as long as this project is approved by the management and it's in order for security, then definitely it's a good idea. So you know what? When I was doing one of the pen tests, I saw a very cool Porsche 911 on the parking spot. I was like, oh, cool Porsche, and that's it. Then, within this customer, I did the password cracking, and one of the girls, she had Porsche 911 password. I wonder if it's the same person, you know? Probably yes, or maybe someone is jealous. So, let's move along. Whenever we are thinking about the whole presentation, how do we deliver the password cracking? A simple exercise. So what I have over here, it's the Python script, DS hashes. You can pretty much download it from the internet. It's an publicly available script. And what you can do, you can export the databases from the ntds.dit in Active Directory, and then you can export them to the text file so that later on, what we're going to see are the user's hashes. I'm going to export it to test 1. So that export is very simple to make. If you are wondering how I get these strange tables over here that I'm using as the parameters of the command, I was speaking on that in the Adventures in Underland session 2 years ago about passwords. Go ahead and have a look. Yes, I don't want to repeat myself, but what I want to show you is that the password extraction, or in this particular case, the hashes extraction, is very simple. And the next stage that you can take, it's simply speaking, to put them as simple as this in any kind of OPH crack like this. So download it for yourself from the internet. And then what we are able to do, we are able to, of course, deliver the cracking. Before I get and explain how does the tool work, of course, let's do Notepad test 1. And what we see over here are different kinds of hashes of the user. You know, I'm so used to hashes right now that when I see E19, I clearly know that this is password with the @SSW0RD, but it's a long story. This one is, we don't use that on the left side because this is an LM hash, which, I mean, I hope it's not supposed to be used in a company anymore. So we take this file, literally, we take this file, and we put it in load in OPH crack, small instruction from the beginning. What we also need, and I'm going to stop that, what we also need is the tables. Tables meaning rainbow tables. We download them from the internet. As you see, I'm using the simplest possible tables ever. And what the OPH crack is doing is heuristically creating the password. For example, we've got April or May. It adds at the end 1, 1, 1, 2, 1, 3, or whatever. And in front and at the end, using the dictionary. So this is the heuristic password cracking. And the reason we could be like, yeah, but why we're supposed to do that? It takes time. Not really. It's very short. You're going to be surprised how fast you can crack all the people's passwords. And you know what? Have a look. I got this Anna Smith here. I mean, many different kinds of examples. And I got, of course, different kinds of passwords over here as well, yes? So the password, they look like this. Have a look. In 1 hour, 26 minutes, on my laptop, I started cracking before the session. I managed to get 25 passwords within the company. And then when you see this Annette01, Mama 1975, yes, you want to deliver the training internally by yourself to your users saying, hey guys, just add one more special character at the end. Your password will not be crackable that fast. We could be wondering, does it matter? Because we've got the passy hash. Yes, it matters, and I'm going to show you this within the next demonstrations. And that matters whenever we are doing the NTLM version 2 authentication, challenge response mechanism, and that is relying on the password strength. Because password, or particularly password hash, it's one of the keys that is taking part in the whole negotiation process. So yes, it matters. So whenever someone is going to be sniffing the network, this guy is going to get that, and then they will be able to become one of these people over here. Not to mention, obviously, reusing passwords, but it's a long story. Okay, so whenever we are thinking about the whole scenario of the passwords, this is, of course, one of the things to remember. This is a small comparison that I put on a slide, that whenever you add one character more at the end, it makes the cracking 50 times longer. Yes, you can easily calculate that. The comparison is like 1 day versus 1 year. It makes a difference. Of course, that depends on the power that we are using, but at the end, it is making the difference. Okay, guys. Next, very grateful subject. But before I move forward, one tiny thing. There is this interesting situation that I'm in. I'm doing, again, the pen test in the company side. There is this admin that jumps in and he's like, do you have 5 minutes? I'm like, no, yeah, I'm here anyway. So he is like, you know, we've got this Veronique. And I'm like, I don't know Veronique and what the Veronique did. And he's like, Veronique, she's got an email. And she's got an email saying that there is a message on Dropbox. And you know what she did? She clicked on this message, and now we've got a CryptoLocker. Can you help us out? I'm like, yeah, of course. Why did Veronique, by the way, click on the link in the email like that? Like, you've got a message on Dropbox? Seriously? This is where we all get... Everybody gets the messages, voice message on Dropbox. And the problem is that maybe Veronique, she was living in a social life. She felt so needed. Message on Dropbox there as well. I'm going to open that. So what happened is that obviously they got something that looked pretty much like this. And you know what's funny? She never told anyone that there was something strange going on. Yes? She was like, oopsie doopsie, yeah. Brush under the carpet, nobody noticed, yes? Until, obviously, the morning. So the situation was that everybody in the morning came to this company, they opened their files, and they got the message like this. And they're like, oh, everyone. Why? Because Veronique, she had access to the file server that everybody else did. Bad news. So he's like, what are we going to do? I'm like, well, as simple as this. I mean, let's be completely not romantic. IT is not romantic. What do you expect me to say? Just restore it from the backup. Mom. And he was like, but, I'm like, uh-huh. So, where was the problem? The problem was that we do have plenty of dollars on IT, and we really have all these fantastic solutions and so on. But what we've noticed is that sometimes, and it's just a generic saying, we don't spend this money wisely. And these are the statistics that are made, yes? They are actually from PwC, and these statistics say that 50% of organizations, they get a malware through email. Okay, that's what we can handle, and that's what we should manage. And the next thing is that 33 out of $115, it's not spent correctly. That's pretty much a good amount of money to be able to implement stuff like AppLocker and a couple of other solutions that we're going to talk about in a moment. Whenever we are thinking about the facts, so whole ransomware, how does it work? Well, it's a small piece of code that is usually sent to the user by email. User receives a message, you got a UPS package, blah, 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 click here to trace it. Oh, by the way, but before you click here to trace it, you have to open this file so that you are able to trace it. And user is like, someone sent me a package, maybe it's my husband sending me the flower. Oh, well, let's see. And that's how it gets to the company. So one of the emails, as you see, this is the email that is actually sent from the customer, starting with a letter A. And on Tuesday, hi Paula, can we reschedule the meeting regarding the penetrations? I think we've got a cryptolocker again. I'm like, sure, yes. You see? Question to you. Do you or your friends had a cryptolocker? Put your hands up. There is about 15%. Okay. So, who knows what cryptolocker is? Another one. Almost everyone. Okay, good. So, whenever we are thinking, of course, about the whole threat, what I decided to do, before we proceed to the small analysis, I decided to present you a small ransomware architecture. How does it work? Because I got for you two things. One thing is pretty much to analyze cryptolocker itself. And what we're going to do, we're going to, in the code, don't worry, it's a session for IT pros. I'm not a developer as well, but I would like to show you how does it look inside, so that we understand the structure of it, so that we can handle and manage that before it comes. By the way, it's usually coming in series. So if your company did not get that yet, maybe you're going to be one of the companies that is happening whenever the attackers, of course, are sending the emails out. They're like, oh, this bank today, yes, and all the emails go in these directions, and one user is enough to cause the problem. Okay, guys. So how does the whole scenario look like? Yes, prepare for the hardcore moment. Okay, ready? Yeah. You ready? Yeah. Be ready, please. Great. Okay. So we've got a PE loader. PE loader, obviously, it's a Windows format. This is something. It's a small executable that has some resource. What's the resource? Resource is a small portion of file that is actually encrypted, and the role of this PE loader, or 10 other levels inside, is to decrypt the resource so that we are able to run it. So this is the first step. Second thing is that whenever a user launches that, the resource gets decrypted, not a big deal, and it could be that it does many times so that we are able to go to the real code. And then whenever, obviously, we've got some portion, some assembly that is decrypted, we've got a resource back. And that resource, obviously, is getting decrypted, and we've got a decrypted assembly at the end that contacts with the server. And then there are two variants that we are dealing with. One variant is using the symmetric cryptography. Symmetric, I mean, if you are like, if you got a choice which cryptolocker you would like to have, yes, the best one is with the symmetric one, because you can make the memory dump and you can extract the keys from the memory, because symmetric cryptography uses the same key for encryption and decryption. Whenever you've got the asymmetric one, you get a problem, because asymmetric one has the, in this particular case, private key stored on the server that you have to pay for in order to get access to your data, because it was encrypted, obviously, with the public key. So, natural state of cryptography. So what it does, it receives the keys, and then, of course, it requests for some money. So here comes the thing. How does the whole solution works out? So let me switch to the presentation, to the demonstration files. Very good. This is my Raggy. We're going to be dealing with raccoons today a lot, you're going to see. So what I'm going to do, first of all, I'm going to use the tool that is called EELSpy. There are many different kinds of decompilers that are available in the market. I find this one nice. You, of course, make your decision. There are about 15 that are really good in the whole industry. What I'm going to do, I'm going to take the original assembly that was used by the solution that is called CoinVault. And the reason why I'm showing CoinVault is very simple. In April, so literally last month, the guys from Kaspersky with the Dutch police managed to get access to the attackers' servers. So all the data that got encrypted is possible to be decrypted right now. It's, if you're searching for the website, it's a no ransom in Kaspersky. CoinVault, that's the name. So you're going to find it. It's very much up-to-date situation. Okay, guys. So whenever we are thinking about, of course, the whole analysis, I got here the coinvault.dll, this particular one, and small analysis, of course, from the beginning. So whenever we have this tiny piece of code, even though we are not developers, and I don't want to really go deep inside, if you want, I can send you the sample and you are able to analyze it by yourself. But where do we start the whole analysis is the program main. Yes, so I'm going to click over here. And that shows me, as you see, how does in this particular case, PE loader looks like. And whenever we go to program main, we've got here, we can click on here, and that leads us to something that is called constructor. And again, not that important, but what matters over here is that we've got some label for array that has the key. It looks very strange. It has nothing to do with technology. It's just a key, probably some encryption key. Another thing is that we've got, of course, the method that is called initialize component. Let's have a look. So we've got the key, initialize component, and it shows us something like this. And this is the byte array. Yes? It looks disgusting because it's very long, as we see. Yeah, so, no, 2 years ago, 2 years past, here we go. So, what is interesting as well is that this label for array that we have has also some other name. So, what is the whole thing about? Well, very simple. There is also an encrypt or decrypt method, as you see, and encrypt on decrypt method probably will use some key to be able to put out some code that's going to extract another code that's going to extract another code. Yes? This analysis took a good couple of hours. Yes? So let's focus on the idea rather than on going into the coding details. So what is really interesting over here is that we've got also here some resource. And have a look, because this resource has the same name as I showed you with one of the label for arrays. So what I'm going to do is have a look. Oh, that looks like someone was not having a good day. Whatever that means. After party code. So what I'm going to do, I'm going to save it somewhere in the CoinVault folder because I would like to analyze it later. Okay, guys. So when we've got the body, so we've got the bytes array, we've got the key, we've got the method, we are ready to go to be able to extract the assembly that we're going to be dealing with in a moment. This snippet compiler that I'm using right now, it's a very simple tool, very handful. If you want to compile something, I mean, you know, you're in a bus or you're in a tram and you're like, what am I going to do today? I'm going to compile something. Yes? So this is pretty nice for that kind of activities. Yes. The reason why I'm showing this is because it's accessible for everyone. Yes. And if you want to do the same analysis as I'm doing, I will share with you this piece of code over here, and you can do exactly, repeat at home what I'm doing. Okay. So have a look. So in this particular piece of code, I am, one more time, using this key. I'm having here encrypt or decrypt. I'm using the parameters data and the key. Key is this. Data is here. This is this array that I copied over here. And I've got this method here, literally Control-C, Control-V. And I'm going to write some result to the console. First, I don't want to export it to the file. I'm just going to write a result to the console. Okay, good. So we are pretty much good to go. So let's do that. So I clicked compile, and then we've got this. And what can I say? It's a question for the sausage. I get a sausage. If you don't believe me, it's real. It's from Poland. I'm from Poland. Yes, we got the best sausage in the world. You know that, especially in Chicago. Okay, so let's answer the question. What is this? Who knows what's that? Yeah.
Decrypted.
Yes, it's decrypted definitely, but for sausage a little bit more. But I can give you because thank you for saying, yes, first, I get a t-shirt if user is going to come to you and is going to ask like, why this is not working? You can always say, what the heck? Okay, so it's waiting for you here. So more, what is, Thank you, but what is this 4D5A? ASCII character, more. Very good. So what is this? It's the beginning of the code, yes? So what is at the beginning of the code that's going to be running? Letters, guys, letters. More? ASCII codes. What if you take an executable, put it in Notepad? I really want to give you the sausage. Yeah, come on. Take an executable, put it in Notepad. What is at the beginning? Good. Letter. Some letters. 2 letters. M file, someone said? MZ, thank you. Yes! Woo! Oh, sorry. Yay! You can share it with someone if you want to, yes? No. Okay, we are all good. Sorry for small torture, I just had to. So, what we're going to do right now, and you are definitely right, I would like to show you, of course, how does it look from the ASCII perspective. So I'm going to compile it one more time. So is this more clear right now? Yes? MZ, this is the beginning of the file. A long time ago, there was this guy, Mark Spikowski, that invented the format like this. And he was like, yeah, it would be cool to stay famous forever. So, well, I mean, he was one of the Microsoft creators, yes? So he put the MZ at the beginning, by the way. So this is where it comes from. Quite nice story at the end. So, yeah, so we've got it decoded. So what I'm going to do right now, I'm going to export it to the, to the 2.dll, yes? 2.dll. So that's what we're going to have. Okay, 2.dll we have already done. And what is really interesting is that I'm going to take this 2.dll. The analysis is going to be very short, yes? So make sure we don't get lost, because here 2.dll, that is the one that I'm going to load in the ILSPy. Yes? So we've got it, 2.dll ready. So here comes the next part. In 2.dll, it's the next analysis. There is some assembly-related information, shield manner, whatever that means, really. Yes, it's something that, well, apparently whoever was writing this maybe was doing jogging in the morning with the shield, or we don't know. So whenever we move forward, then we've got, of course, the program where we've got also the information, some piece of code to analyze. And I mean, it's endless. Well, it has the end somewhere, but it's all the time like this. Why? To make the whole analysis to be more difficult. But I want to show you something interesting at the end. So whenever we are thinking about and having a look about the code itself, what we can read, for example, over here is that if you would like to take this code vault and if you would like to analyze it in the environment when there is a sandboxy, it will not execute. Whenever you're going to be running things like Wireshark, it will not execute. Whenever you're going to be, for example, running it, have a look. On the virtual machine, this is WMI query. If it returns your Microsoft Corporation or VMware or anything like this, it's a virtual machine, yes? It will not execute. Nasty bastards decided to hide it. Well, but somehow we have it, yes? And we're analyzing it, yes? So anyway, let's have a look. So next thing, and I will just tell you, based from the analysis, it looks like the D method is going to be the one that's going to execute first over here. And what we see over here is that, long story, but we are using something that is called XML serializer. That means that we will have something to do with XML, yes? So we will need to implement it in the whole idea if we would like to decode whatever is in there. Okay, guys, one more thing. If you have a look at this D method, it technically takes 2 parameters. One is the key, another one is the resource name. And in this particular piece of code, it goes through something that is called reflection, which means that it's going to use the parameters from the defined in the previous assembly. The developer stuff. But whenever we are thinking about trying, okay, so is it possible to extract the next resource? Because this stuff, this resource, is the one that's going to get decrypted right now because of the D method with the key and the resource name. We've got the key, we've got the resource name. Remember the label for Ari? That's exactly what we need. and we need the encrypt or decrypt method. And then we are ready to go. Plus this XML serializer, because apparently it's going to have something to do with the XML. Making the long story short, I got another piece of code over here defined where we are actually, have a look. Oh, one more time, sorry. Defining, of course, this particular key. We've got the name of the assembly. So this is what we need. We need encrypt or decrypt, data key. Very good. And then we're just going to file write all bytes to the 3 and the binary file. And then we return. This one we don't worry about right now. Okay, guys. So next thing, it's simply speaking to run it. And when we are done, what we're going to see pretty much, it's the exported. Let me run it one more time because something did not start correctly. What is this? Let's see. Yeah, unreachable code detected. Oh, okay. Let's see why is that, because it's kind of strange that we've got it like this, because we should, no, we've got this coin vault, we've got the assembly. Oh, no, it should be fine right now. Yes, I got it.
Because you have the return statement in.
Exactly, yes. Very good point. So we've got it already, yes? Here we go. So 3 bin. Hey, you want to come here? That would be actually nice. Okay, thanks. So we've got this 3.bin, yes? So what I'm going to do right now, but thank you for your suggestion, I appreciate it. So what we're going to do, we're going to use the old as world notepad, and we're going to put this binary file over here. I know that maybe it's not the best to open it. We could use some hex editor or whatever, but the reason why I'm showing notepad is because the output is pretty. You're going to see that. Yes, it's going to take a while. This not responding, by the way, if you are curious, it's not because Notepad is crappy. No. Notepad is very old school, that's why. And there is a library, it's called the GDI32.dll. It's a primitive graphic library. So when the Notepad says not responding, you should be like, okay, I'm sure you are hardworking. Take a coffee or whatever. That means hardworking. It's just a Notepad way of communicating this. Okay. So what are we going to do? Well, let's see. I mean, for now, we already see that has something to do with the XML. It's still not responding. Okay, let's give it a chance. And we've got here we go. This is so much better. Oh, come on. Seriously, Notepad? Yeah. No, come on. Just show yourself. Yeah. It's going to load whatever it has to load in a moment. There's going to be that's exactly what I wanted. Yes? That is the evil. Yes? This evil, called stub bytes, is the one that we would like to decode. You see XML purely. Yes? So we need to, what is this? Base 64. Yes? We need to take that and we need to analyze pretty much what is this piece of code about. So what I'm going to do, as simple as this, in the snippet compiler, one more time. So let me go back. Here we go. I'm going to, pretty much comment those 2 lines, so we don't need them. And I'm going to run further, and I'm going to extract the code to 4.bin by later on deserializing it. So decoding. So let's do that one more time. So I'm going to start that. Very good. That looks positive, yes? And then the next story that we've got, it's pretty much the bin, 4bin, that I'm going to put into the ILSPy. Let me put it like this. ILSPy is not handling putting the code, just drag and drop fantastically. So this one, put, and then let's analyze what is inside. Let's have a look, because that should be, let me see. What is the whole scenario about? Let me do this one more time. Something is kind of strange. One more time. Sorry about that. Small confusion. Yes. So we've got. Let me bring our snippet compiler one more time, because that got closed for a reason. Let me see. Oh, sorry. Small technical issue. Here we go. Now we are back on track. And we've got a snippet compiler, and I'm going to open the whole thing one more time. Okay, so this is our snippet compiler, and sorry about that. Quickly, back on track. This is it, and we've got the whole analysis ready. Very good. We are on it. Okay, good. So without the explanation, one more time, of course, let's do that. Bang, bang, and then bang, bang, and then we are ready to go right now. So let's do this. Okay, now we've got the code back. Very good. So we've got this for.bin, and then I'm going to take this and I'm going to put it to the solution over here. Now, what's this? No, I actually got it disabled for that. So that shouldn't be an issue here. Okay, let me see. Where are we going to get with this? Yeah, I will just show you the result at the end. And that's what we're going to do. I wonder why it did not extract correctly. Let's see. Let me take this. Put it here. Now I got it. Okay, I'll be back on track, you see? Good. So there is something that is called locker. But locker has a message for us, yes? And your worst nightmare, whatever it means, what we can find over here, it's actually pretty interesting, because in the whole code, and that is something for, I believe, guys from China, I'm just kidding, it's a code that has been obfuscated, which means messed up inside. And this is something that, of course, contains different kinds of code. For example, one of the things it contains is the encryption or decryption function over here. So whenever we decompile the code, we can see clearly over here what kind of cryptography we are using. And that's what I want to show you. You see, I mean, there are many different kinds of levels. Yes, it's not over. Now we need to do this couple of levels more. I will not torture you with this, no worries. But that is something that shows us what kind of cryptography pretty much we are dealing with. So whenever we are thinking about the whole scenario, yes, see how complex is that? I mean, we have to decrypt and decrypt and decrypt a couple of components over here, including, of course, one more thing that I want to show you. Kaspersky got this CoinVault decryptor, and that was issued recently. What we can find over here is that within the decryptor, either I can just go to the sorry, let me go to the decryptor. Here we go. What we can find over here, so we've got the main here program part. We can see here that we are using the same parameters as if it was in CoinVault, which means it's asymmetric cryptography, which means probably it's going to work out. If you go deeper and deeper and deeper, you're going to find a lot of interesting files over here, interesting resources, how the coders were working on it, including one research at one of the stages that you're going to find out here, different kinds of resources, including the software icon. There's actually a little bit nicer version here. So we've got this, and that should be one of the, no, not really. Okay, so this is the one. It's kind of funny because normally what it says is in the God we trust, but what these guys have over here, it's a Bitcoin in the cryptography we trust. Well, apparently cryptography brings them Bitcoins, doesn't it? So what I want to show you after this small analysis that you can do, but we see that the code is pretty complex. It's the next subject, which is, at that point, CryptoLocker in action. So whenever we are thinking about the whole solution, yes, you see that there are many different kinds of modules. But question is how we are able to prevent that without understanding how it really works. One of the things that is really important is that whenever the user is the local admin, what is deleted are shadow copies. So if you want to receive your files from shadow copies, forget about that. When the user is just a user, the data gets encrypted. And in the way how it gets inside, it's usually through temporary folders, app data, and that kind of solutions. Whenever, obviously, the CryptoWalker is working and you've got access to some kind of network share, yes, it's going to encrypt it too, yes, if you do have a right access. It's very nasty. A couple of more things is that whenever you try to kill the process, usually it has another process. So it's better, instead of killing, suspending it. Yes, and I'm sure you will hear it on a Marko Sinovic session as well. Fighting with malware, yes? Don't kill the process like that, suspend it. Make a memory dump, analyze it, yes? So in this particular case, what I want to show you, and if you want, I'm happy to share it, it's pretty much ransomware in action. And what kind of ransomware we are talking about? Okay, so let's move on. So this is the Freddy's desktop, yes? Freddy has, simply speaking, received an email. And one of the emails that he received, it's from Bobama. I don't know if you know who's that. By the way, to spoof an email like this, it's unbelievably easy, yes? So he receives an email from the White House, Bobama. And Bobama apparently sent him $100 so that he can pick. Do you recognize the format, more or less? PayPal. I actually took exactly the format like this. So their Ignite user just thought that you would like to know that somebody sent you $100. So what the user does, pretty much, he clicks Get the Details, and he's got this transaction receipt. That's how the infection usually looks like. You're going to be like, yeah, but this is like, I mean, who will really do that? People do. That's why we love them so much. So we're going to save it, well, whatever. We can save it in downloads. Yes, so user really saves that. Let's go to downloads. And what it sees, it's the transaction receipt that is zipped. So what we're going to do, simply speaking, we're going to extract it. Yeah, let's do that. And you know what is funny? Is this. Transactionreceipt.pdf. Is this a malicious PDF? Well, probably, if we are talking about that, but it's not really the PDF. It's an executable. As simple as this, guys. Well, default Windows settings has the extension being turned off. We know, you know, I mean, they don't. They means the other ones that are not here, the users. And they're like, transaction receipt. Well, why not? Let's have a look what's going to happen. But you know what? Because I know what's going to happen, before I'm going to click on something, I would like to show you that on the desktop, I got some docs. Good, some copy. That is actually in Polish means Alice has a cat and dog. Yes? Whatever. So it's some document. I'm going to open it. Yes, so let's do that. Transaction receipt. This is a security warning that it's not apparently read enough. Yes? Of course, user wants to open it. It's intentional. We could be like, yeah, we will never click on that. I know. It's not the point. So user is like, okay, I want to open that. Yes, let's do that. And that's what opens. Yes? Whatever, transaction receipt. So what is happening underneath, and that's the problematic situation, is that the keys, they got encrypted. I can show you. We can open it in Notepad, for example. It's the whole strange characters. And there is a message that your data was encrypted. By the way, our team has written the Raccoon Locker, as we like to call it, Raccoon Logga, that encrypts your files. Yes, it does. But this is the one that encrypts your files in a controlled way, so that you can learn how does it work. It's actually better than the previous one that you saw because you use a little bit better functions. It's a little bit more fast if it's about encryption. And what is really nasty over here is that we're not using any kind of symmetric cryptography. We're using asymmetric one. And you know what we are doing? How nasty that is. Every single file is encrypted with a different key. So if you want to earn thousands or a lot of dollars, that is perfect, yes? Pay a small donation. Okay, Raccoon is dead already, but anyway. My point is to show you how we are able to prevent that, yes? And that's what I believe what you came for as well. So what I'm going to do, I got this CQ decryptor. It's the file that you can use as well to be able to decrypt the files and play with them pretty much as you want, yes? How does it work from the other side? Well, the other side is actually very, very, very straightforward because the other side is the server that you will need to set up for yourself, but it's actually very easy. And in this particular server, let me show you how it works inside, and that is our web server. Pretty much, I'm just maintaining the keys, yes? And that's exactly the whole idea. Demonstration is coming. And these keys are maintained within the server's memory. So if you would like to have your data back, you need to maintain the session. Just send me an email if you want a Raccoon or Loca, so that I will explain you how to set it up and so on, yes? So the whole idea is in here, keys. There is a file where we are maintaining all the keys, yes? And that is something that you have to have in order to decrypt your files. Okay, guys, long story short, whenever we are thinking about the mitigation, yes, how we are able to prevent that, well, we could be app blocker. But not every version, since you know, of Windows has an app blocker, right? So if we don't have the Enterprise Edition, when we could be like, what we are supposed to do then? Here we go. So there is a thing that is called software restriction policies. But we could be like, yeah, but this is a crap. Kind of agree, kind of disagree. That depends how we're going to implement that. Yes, it can be bypassed. Yes, it can be. Mark Russinovich, when he was not working for Microsoft a long time ago, he wrote a tool, it's called GP Disable. For an unknown reason, it's no longer on sysinternals.com. But we've got it on our server, by the way. We need to keep the history, right? So go ahead and download it. So let's move along. So what I'm going to do, let's kill this guy because, I mean, my heart is broken when I look at this. Okay, so I'm going to just kill the process, yes? Okay, this guy goes out. So there is something that is called CryptoPrevent, and I would like to show you a couple of things related to that. CryptoPrevent is one of the, it's one of the famous solutions that is supposed to, by implementation of the software restriction policies, secure your desktops. Does it work? It's actually pretty nice, but I would like to show you when it's not working, so that we know exactly what are the its weak points. What I'm going to apply, it's the default protection. Set it and forget it. Well, that I kind of don't trust this kind of sentences, but default is actually pretty good. So let's select it, and then what we're going to do, as every in IT, I'm going to see the advanced options. Yes, what are those advanced options about? Well, first of all, what does it mean apply protection and that's it? It means that all of the stuff that is trying to execute itself from app data, user profile, or recycle bin, very typical place for malware to be in, VSS admin, remember, to remove the shadow copies, Cypher, and a couple of other things like CPL. It's not only exe.com, DLL, it's not only the place where the code can execute from. We've got a PIF, screener, a CPL files, and so on. This is where the code can come in. One thing is though missing, but that's exactly where I'm going to. So this is beautiful. What we're going to do, we're going to apply the protection first in order to be able to, of course, here we go, applied protection, refreshing group policy. And what he's going to do is going to ask me for the reboot, so I'm going to do that. So it takes a very small moment. And what's going to happen, yes, I want to restart now. What's going to happen after the restart, the software restriction policy rule is going to be applied, because this is something that works based on the software restriction policies. It's going to create me a huge amount of rules where, for example, stuff like pdf.exe, as we had, is going to be blocked. All this kind of very creepy namings that are relying on the fact that user has hidden extensions of the known file types. Okay, guys, so right now, the protection successfully applied. Very good. So here comes the thing. I've got this decryptor, yes, that works over here. It's just a small tool. I'm going to copy that. Or actually, you know what? Let's do the evil. Let's do the CryptoLocker one more time, or RaccoonLocker. Yeah, so we've got this transaction receipt. So question is, will transaction receipt execute? Yes? Run. Yeah, the system blocked this program. Success. Yes? Then user will not be able to run that. Okay, here comes the thing. I'm going to open up the CMD, and I'm going to take this body, and I'm going to rename it to an executable, because maybe the pdf.exe pattern is working. So let me paste this here, and I'm going to rename the transaction receipt pdf.exe to transaction receipt.exe, as it originally should be. Yes? Enter. Now, the bad news is that the question is, of course, will it run or not? So let me show you. So I'm going to do this, and of course, it runs. So there was clearly a pattern saying, as you see, there was clearly a pattern saying that the pdf.exe, it's not allowed to run. Let me kill this guy. Okay. What then? Yes, because this is not perfect. All these executables that are there, that are in the downloads, that are in desktop, obviously they're going to run. Because where they will not run, it's app data. Yes? This is where normally malware is executing from. So let me do, of course, one more thing, because I want to use the CryptoLocker so that we've got the clean data decrypted. Okay, now, next part. If we are saying then that this data, it's supposed to execute from the app data roaming, and this is where it's blocked, I'm going to put it here. And let's execute it, and let's see if it's really going to be blocked. And it is. This is from app data, not a surprise. You know, guys, I mean, as I said, I like to provoke the situations, yes? So what if I put it in a folder? Yes? Will it execute? Let's do that. It will not. Okay. Let's keep going, because I kind of don't believe that. What if I put it in the folder number 2? Yes? Will it execute it? Yes? Let's see. Oh, it did. You see where the problem is? Yes? Why not, being a smart malware, normal malware, browsing through directories, creating multiple folders and putting yourself over there? That didn't work. Okay, so we're like, yeah, this is not bad, don't get me wrong, I'm not criticizing it. I think it's actually pretty good. But when we are thinking about the whole idea, we could do better, yes? So let me show you how better we could do. So what I'm going to do, at that certain level, I'm going to go to this place, and I'm going to say, you know what? I mean, I like you, but this time I'm going to do some hardcore setup. And that hardcore setup means I'm going to implement the software restriction policies with the restricted option, which means none of the software that I directly define will be allowed to run. I have to reboot. So within all those rules, it's really nice, but rules are very simple. And of course, you could create patterns and patterns and patterns to the whatever level, yes? But then maybe malware is going to be smarter than you are, and it's going to create even more folders. So it's nice, but not that efficient. Okay, guys, so what I'm going to do, I'm going to implement right now software restriction policies. Yes. Software restriction policies. So let me go to the SecPol, or it could be through group policy, doesn't really matter, where I'm going to specify software restriction policies. So let's create the new software restriction policies. Very good. And then I'm going to specify security levels where disallowed is going to be the option. Now the default is unrestricted. I want to disallow everything. Do you want to continue? Yes. Okay, so this one is beautiful, which means every single executable that I run should not be running. Let me see. Oh no. oh no, maybe I should open Adobe then. Oh no. Adobe Reader, blocked. Why is that? So this beautiful solution, yes, blocked me all the links, LNK files. Nothing is going to work. Yes, like this. As long as you're using LNK, it will not work. So have a look, because that's going to be interesting. If we go to the designated file types, we can go to the LNK, yes, remove, yes, very good, okay. For example, I can start right now this guy. Why not? Can I start this guy? This one starts, yes, Internet Explorer, it's starting. But why I cannot still run Adobe Reader? And it's a question for the t-shirt. Not signed. What was signed? It's not coming from Microsoft. That's true, but this is particularly not the reason. MSI could be. You know, you are all perfect because you were like, oh, something interesting. Something. You know what? SRP, it's unbelievably simple. Yes? Program files. Who said that? You did? For you. Waiting here. Thanks so much. You know, what is really interesting over here, it's coming from program files, yes? But if we go to the additional rules, which are defining us, where the software runs from, program files, it's there. Okay, but what is not there? Then, and have a look. The rules, you see this tiny detail over here? It's blocked. So don't be discouraged, because SRP really requires us from some additional work always. So what I'm going to do, I'm going to specify, in this particular case, new, and then it's going to be the path rule. And over here, I'm going to specify the, as you see, x86. Yes? And we got it. Okay, good. Adobe Reader works like a charm. Yes? So first step. Okay, so this is nice because we've got all the software configured. But you know what? Here comes another email. Yes? None of the executables can run. Yes? Only, of course, the ones that are from program files and Windows folder. So here comes the next email. And the next email says, hey, it's Bobama again. I sent you $100 for the second time. See the receipt. And before I do that, yes, this is sneaky. Before I do that, you could be like, yeah, but the software is malicious code. It's not supposed to run only in Windows, and user has no access to Windows folder. It has no access to the program files, he cannot write them over there. He can only read from there. So what's going to happen? That's the tricky part, you know? So let's start one tool. And that's going to be actually quite nice. So in the program files, I put to myself Protsmon, because everything can run from Windows. Another interesting part, if I try to start it, yes, it says, meh, sorry, but the program has been blocked. Why? Have a look at the path. You see the path? Yes, because the Protsmon extracts itself to the app data and so on, and that's not the place where the code can run. So positive news, because this is where AppLocker or CryptoLocker and a couple of other things gonna be in. So what I will just need to do, let me create another path rule that's gonna pretty much, or maybe hash rule, it's gonna be better. Hash rule, different one, that's gonna pretty much cover the Protsmon 64. That is extracting itself when you execute it to app data. Yes? So this is kind of confirmation that pretty much things will not work and will disallow malware from running. Will it? So I'm going to start Protsmon for the analysis, and let's do that. And in this particular case, well, I got a bunch of filters here configured. I'm just going to remove them all so that we've got a default configuration. Apply. Okay. Protsmon is working. Okay. I'm going to go to transaction receipt. Very good. Before we launch that, let's move along. We've got here docs, And as you see, these particular docs, they are encrypted. So we need to pretty much decrypt it first. This one, of course, because this one, it's blocked right now. Okay. So I'm going to put it where am I supposed to put it. And in our case, it's going to be, for example, program files. Let me put it over here. Continue. Okay, let's do that. Decryptor, I'm going to decrypt the files. Very good. The files are already decrypted, so we see Allah has a cat. And here, I'm going to open up the document. And let's see what's going to happen with the whole story. So Word is coming up, then protected view. In order to view this document, enable document, enable content. User will be like, okay, this is some receipt, I want to get it. We will never click on it, I know, but user will. So when he sees that, macro settings are in the user's profile. Oh my gosh, I don't like that. So enable content, and the user's file kind of magically underneath got encrypted. Where is the cryptolocker? Where is the stuff? You know what happened? Temp, it's a good thing. You know what happened? Underneath, I used a malicious file that can run regardless. Question is, what kind of file is this? And I will not tell you until we do the analysis. Yes? So how do we do an analysis of that? So we stop the monitoring. I have turned off in Proxmox the registry settings, as you see. Yes, it's there turned off. We are just working on the files. What we will see over here, it's actually kind of fun. We can go and just view the processes. There is WinMord that started, and there is a couple of other things. WinMord is there. PowerShell is there. See my point? Wait a sec. PowerShell did the job, yes, but how? So, what I'm going to do, let's do, maybe not the by process, but let's do the tools, file summary, by folder, and I'm going to filter out, that is a really nice technique, by the way, I'm going to filter out all of the events based on the user and his data. Oh, this is Freddy, and his data. So I'm like, where was the data encrypted? It was encrypted on a desktop. So let's take the desktop and let's filter out all of the events that were related to the desktop. And let's see what happened. Okay, so I got this PowerShell filter out. And I'm like, okay, what was going on? I mean, it's clearly browsing through the different kinds of files, yes? So if I double click, I got here the process. And I got here the PowerShell encoded command that was launched within the PowerShell. Question is how it was launched. So if we take this encoded command right now, we can copy the whole thing. Control-C, copy. I got over here a tiny script, the code, where I'm going to convert base64 to, in this particular case, of course, the regular text. And what I need to do, simply speaking, is to start PowerShell and try to decode the whole thing. And what it shows me, it's the simple AES cryptography. The key is 1 to 16, so very simple in this case, where I'm encrypting the data. But we could be like, okay, that's all good. But who launched the PowerShell? Good point. Something in a macro, yes? .NET, close, script, close, VBA, close. Let me show you. Let me show you, because it's actually quite geeky, yes? I don't have any sausage, by the way, if you were like trying for it or something. Okay, so let's have a look. So, do you know what was opened in the operating system? LNK file, a shortcut. Shortcut contained PowerShell and encoded command. If you get that shortcut, of course it's going to run. What was going to run underneath? PowerShell, because it can. And that particular LNK file, this was the one that we have removed because we wanted to have comfortable work. You see the point? So what is the thing about this LNK and how it came out? So there is some binary file that was there, and we have changed this to LNK. Why? Because if you do have any kind of app locker implemented, I want to run. If you have implemented it, any executables coming from the operating system, no problem. LNK, it's completely transparent, right? So how do we know pretty much that that was an LNK? By, of course, looking at the macro, that's one of the things. But another thing is that then we can, of course, do one thing. I'm going to remove this filter, okay, and I'm going to apply it. Control T shows me the process tree. I'm going to go through this process tree, and I'm going to find where was the PowerShell. We see that it was actually launched through WinWord. But what exactly in WinWord started that? So I'm going to go to include, I can double click and then include the whole tree. And then I'm going to create additional filter where category is, in this particular case, right. And then OK. Yes, I want to know, of course. So what I will see over here is that this is the whole WinWord running, the whole idea with WinWord. And pretty much over here on the edge, when WinWord starts and when the PowerShell starts, we see that to update a local temp, there is an LNK file that was extracted. On my previous session, I was saying, in order to secure your environment in the place that you don't want that kind of situation to happen, disable PowerShell. Sounds like, oh, what did she say? Why do you say that? Well, simple thing. Users are not the ones that are using it. We could be obviously using this for the administration, yes? But I just want to show you, it's actually quite hard to manage. So this is a perfect moment where malware is able to get on board just because we are not managing the LNK properly. Okay, guys. So, questions? No? Let me show you one more thing. Yes? We've got this data that is obviously encrypted over here. So let me bring it out. And I got here the decryptor. It's also LNK, so decrypt. I'm going to encrypt the data so that it stays decrypted. I would like to show you a pretty interesting mitigation, because we could be like, yeah, but how we are supposed to block LNKs? Well, it's not easy, I said. Therefore, there are two ways to play with those. One way, let me show you, is to play with something that, or I'm going to just go to tools, here we go, tools, to create something that is called an NTFS sparse file. NTFS sparse file creation, we wrote a tiny tool to do that. It has no user interface, by the way. You just double click on it and it just runs. So what it does, it's simply, yes, this is the, sorry about that. I need to, of course, delete the saturation policies. You need to double click on it. And what it does, it creates different kinds of files that if you go to the properties, this is what the NTFS sparse file is. If you go to the properties, it's visible on the disk as 100 megabytes in this particular case, but for real, it takes a small amount of space. If your disk gets full, and you're going to have a bunch of those in a different strategic locations in your file server, what's going to happen, CryptoLocker is going to be like, oh, another file, I'm going to encrypt that dumb one. And this one pretty much is going to fill up your data to the defined size of the file on the disk. Make sense? But for real, it does not take your space. So this is the first mitigation, yes? And you can have the warning, the performance counter alert, that when your disk gets full or any kind of warning like this, you're going to be notified. Next thing that I want to show you is actually pretty interesting. It's more interesting than that. Because what I'm going to do, let me do this. I'm going to, first of all, start the CMD. Yes, that's the one thing. But I'm going to start the CMD as an administrator. And what I'm going to do, I'm going to create in the, so let me go to the user profile and then desktop. And I'm right now in the desktop of Freddy. Let me enlarge that. And I'm going to create over here the loop using the built-in operating system mclink. So I'm going to play with the idea of mclink. So let me, of course, enlarge the whole font so that we're going to see it. So right now, well, it goes like this. First of all, I'm going to create a folder that is called loop. Yes? Next stage, I'm going to create the mclink. So if I go to the loop, yes, I'm going to create the mclink. So mclink, clink, yes. So the symbolic link. And in this particular case, I'm going to /d. I'm going to specify the name 0, and I'm going to specify the directory that's going to be pretty much like this: ### loop. Yes, and I've got the mclink created. Next thing, I'm going to do the same story, but I'm going to name it once. Yes, so 1. So we've got it. What will happen if if we do dir, we've got these two guys. If I do dir and then a s b, so to browse all of the directories underneath, we've got, of course, these two. But if we do dir just like this, and I'm going to do, for example, dir, and I'm going to query one of the folders over here. Yes, I'm sorry, dir, of course, 0. Yes, it shows me, of course, file not found. So dir, and whenever we, well, let me see, because something is, it did not do wrong, did not, let's see. I'm going to enter 0. It doesn't show me that. It's kind of strange. Let's see one more time. Can it enter? Yes, because let me see. Because we should have that. Yes. Yeah. Let's do it. Let's do it. Yeah. Let's do it differently. I'm going to open it like this, and I'm going to do dir loop. No, come on. md one more time. I'm going to do that by hash loop. Sorry about that. Here we go. And then let's enter the loop one more time. And then let's do mclink. And then I'm going to specify d and then 0. And then it should be fine. Oh, of course, because I made the typo. That's my fault. Sorry about that. Here we go. I want the other command, which is the number 1 loop. Makes sense? It does. Okay, now it's perfect. So here, right now, if I do, of course, dir, and then with the loop. Oh, come on, what's that? It does. It should be linked to each other. That is the issue. Yes. Let me see. Because what we are expecting to do to go right now is to have it rolling. Yes. Let's see what is the whole idea about. So we've got the mclink created. We've got our folder created, and if we do dir asb on right now, oh yes, perfect. Sorry about that. Very good. So you know what are the details? That goes, by the way, putting the long story short, about 60 levels down. Yes, that's the whole link. That means that if we are browsing about 1,000 folders within the second, yes, then whenever we are thinking about, whenever we are thinking, of course, about the whole structure, we've got 2 to the power of 50 to browse through the whole infrastructure. Do you know how much year is? How much second year has? Exactly. So year is 2 to the power of 28. Yes? That goes for 2 to the power of 50. Whenever we are calculating this, that means that this beautiful loop is going to go for about, calculated, it sounds like, whoa, about 4 million years. That means CryptoLocker or any kind of mechanism like this, touching this kind of folder will loop. And we have practiced this mechanism on the plenty of pieces of the real CryptoLocker, and that was really a dumb piece of code hanging on the solution like that. Why not putting this kind of structure again into the strategic places? And I know AppLocker, I know SRP, but as you see, simple NNK. And that was something that made the bad job, and we are, thanks to that, able to, of course, prevent from the solution like this. 4 million years. I mean, it's not your grandchildren that's going to be watching this. Okay, guys. So making the long story short, awareness is a very important case. Whenever we are thinking about users, we should never expect that the user is going to be a super, hyper, nice specialist on security. Yes? Okay, I'm finishing. Yes? You want to come in right now? Okay. So we never can expect that. Whenever we are thinking about the whole theory, yes, theory is perfect. Yes, user can learn how to play with the awareness. Whenever we are thinking, though, about practice, with the whole experience, we need to have, of course, behavior in place. Users will not be able to identify the threat if, of course, they don't know how the thief looks like. And I was the thief. Nobody was able to identify me as a threat because people were not aware that things like that can happen. So making the long session short right now, within the whole summary, the culture that we are playing with, it comes simply with understanding. And if we're going to understand what kind of data we are protecting, or we can answer ourselves a question, can we afford to deal with CryptoLocker and anything like this, then security awareness is going to come to place, and whenever we implement it with the support of the management, hopefully users will no longer be a part that's going to, at the end, annoy us so much. And with the current technology that we have, we can create and plan accordingly the solution that will remove the users from this very sad chain of security. So that was my part for the session. Thank you so much for coming. One more thing to mention, if we're running in US something that is called Secure Academy, and this guy over here has some $300 discount vouchers for the different kinds of security stuff. If you got the voucher, then he is standing over here, and I got them as well.